Hello and welcome to another maths video. Today we are talking about time series data. And time series data, this kind of marks for us a big shift in our unit. So far in our unit we've only looked at single variable data. So we had a bunch of scores. With our scores we've done things like find the interquartile range, we found standard deviation last lesson, we found mean, median, mode, and we've graphed them all. Whereas now we're going to kind of leave that behind a little bit. We're going to talk about bivariate data. So bivariate data, bi meaning two, like bicycle, two wheels. Bivariate data is going to be linking two things here. So instead of getting a data point just by itself, someone's height being 175, you're going to get two pieces of data coming at once that are linked. So the person might be 175 centimeters tall, they also might be 80 kilos. And that goes together as one unit or one person. The first introduction to this we look at really is time. So when you're looking at data over time, you generally are looking at bivariate data. So I've just given you guys an example here, and this is 2016 weather data for North Parramatta. This is the average maximum temperature for each month. So down the bottom, on my bottom axis here, you can see I've got listed the month, and I go from month 1 to month 12. So like January, February, March, April, May, June, July, August, etc. And down the side here, one is January. So January, 28 degrees was the average maximum temperature for the day. In February, 29.3 was the average maximum. So what I'm getting here, I'm linking, it's almost like a coordinate, and it is a coordinate if you like. I'm graphing time unit here is 1, and my temperature unit is 28. So time unit, temperature, time unit, temperature, time, temperature, time, temperature, time, temperature, time, temperature, time, temperature, etc. In the case of time, looking at time series data, you may also have on the bottom axis the actual months written. So January, literally saying January, literally saying February, March, April, etc. Just for graphing, I prefer to use a numerical unit. So this here is time series data. It's the temperature for North Parramatta. As you would expect, summer, month 1 and 2, it's kind of hot. Month 3, it's also pretty decent. Then we're really seeing a decline here through, this is autumn. We see winter here, then we see spring again. And our hottest temperature is actually in December. The average there, almost 30 degrees, or 29.9 degrees per day in December. So that's what's happening here. That's our trend over time. With weather, we would expect that. It's big here that we can talk about trends. You would talk about this being a wave because the data obviously fits a wave sort of a pattern. Looking at a second example of time series data, what I've got for you, this one here. So similar sort of setup. What I've got here, this is the temperatures, the average daily temperature from 1980 to 2016. So the years there literally written, numerical data, very nice. 1980, the average was 24.5 in 1980. 1981, it decreased by 1.4 degrees. Climate change, yeah. So this is the data, years, time series, always time down the bottom, whatever else up the side. So here we're talking about temperature. You might talk about rain, you might talk about sales, you might talk about anything depending on the context. Sales will be a big one as well. So again, talking about trends, so you want to talk about, well, I mean, global warming is supposed to be a thing. Is there some trend here? Is the data trending upwards year by year? And it looks pretty flat. We'll look at a bit more detail, putting a line through it to actually get a pattern later on. But I'd say it's pretty straight. So you could say it's linear. So linear, of course, being a straight line graph. But yeah, in short, time series data, time on the bottom axis, some other unit up this side axis in here. In terms of if you are going to graph it, I would always recommend graphing. Graphing is a very nice thing. My x-axis here, my y-axis. In Desmos, I can come along, hit my options settings, and change it. So my x-axis is year, and my y-axis is going to be temperature. And you can see those just getting onto my graph there, now year and temperature. And that'll be pretty important later on when you are doing some more connecting sort of graphs. So this is just a basic example. We will look next couple lessons at linking other types of data, so linking how much study you do to what marks you get as well. because we can monitor both of those. We can put in a number for number of hours studied and mark, hours studied, mark, hours studied, mark, over a whole class and see what the connection is. But yeah, that's introduction to bivariate data. I'd say it's probably more interesting because you do get the connections in there. Obviously, if you have one group, so say you had the years here, you could find the average year, which is probably not very helpful, but you could find the average temperature, you could find the mean temperature, the mode temperature, etc. for that. You could go into quartile range, standard deviation, the whole lot, to see how unique, how rare some of our scores are. Otherwise, that's bivariate data, that's time series data, and thank you for watching.